All right, we're going to get into Algebra 2 level systems of equations. And we're going to have 4 lessons. The first is going to be on writing systems of equations, and we'll do that today. Then we'll talk about how to solve them analytically. That means using algebra operations like you learned in Algebra 1 to solve them. And then we're going to take a quick break from solving systems of equations to learn about what a matrix is and how to do matrix operations. And then we're going to put that together with our solving ideas to solve them using matrices, which is going to allow us to solve them really quickly if we have a calculator. Okay, so let's look at what we're doing today. We're going to be writing systems of equations. And before we get there, let's talk about what a system of equations is. A system of equations is when there is more than one equation with more than one variable. You need one equation for each variable. The solution is all the values of the variables that make all equations true. We'll try to talk about how to find these solutions more next class. But for today, we'll be talking about how to write them. So a system of equations with 4 variables needs how many equations to go with it? Well, you need one equation for each variable. So if you have 4 variables, you would need 4 equations. In Algebra 1, you largely just dealt with systems of equations that had 2 equations and 2 variables. In Algebra 2, we will almost entirely be dealing with systems of equations that have more than 2 variables. Okay, so let's look at what I mean by a system of equations. There are 3 numbers. The biggest is the sum of the 2 others. So the biggest is the sum of the 2 others. The smallest is 12 less than the biggest. The smallest is 12 less than the biggest. And multiplied together, the product of the 3 is 51. So we need to define our variables. We need to understand what our variables are. And variables are largely going to be quantities we want to know or don't know. So what are the things we don't know here? Well, pretty obviously here there are 3 numbers. There's the big number. There's the middle number. I don't know. There's some middle number. And then there's the smallest number. And it's really helpful to explicitly write what each of your variables is and choose a letter for it. I think for the smallest number, I'm going to choose A, because I know A is the smallest letter in the alphabet. For the middle number, I'll choose B, and for the biggest number, I'll choose C. And that'll help me remember, like, this in my mind makes a lot of sense because I'll remember that A is the smallest, C is the biggest, and B is the middle one. But, you know, I could use X, Y, Z. It doesn't really matter what letters I use, but these are going to be the variables that represent these things I don't know. And now I'm going to write the equations. Now, since there were 3 numbers that I don't know that I want to find out, how many equations am I going to need? Well, I'm going to need 3 equations. And I hope I have them. Each equation is going to come from a relationship. So it's a relationship between the variables. So what are the relationships between the variables? Well, here's one. The biggest number, let's write what variable is that? The biggest number I said was C. So the biggest number is, that means it will be equal to the sum of means add together the 2 others. So what are the 2 others? That's the smallest one and the middle one. So this says the biggest one is the sum of the 2 others. So my first equation, and I need 3, is going to be that the biggest one is the sum of, I need to add together A and B. So A plus B. C is A plus B. The biggest one is the sum of the 2 others. Hopefully we feel good about that. Our second relationship is the smallest is 12 less than the biggest. Try to write this one on your own. The smallest is 12 less than the biggest. And hopefully we saw here that to do this, what we really want is we want to say what each one is. The smallest, that is A, is A equals, so A is going to equal 12 less than. 12 less than means we're going to subtract 12. Be careful. It is not 12 minus. It's 12 less than. We'll take whatever this is and we'll subtract 12 then. So 12 less than the biggest. The biggest was C. So it's C minus 12. Be careful. If you wrote 12 minus C, and you might have, that's not right. 12 less than something means we will take whatever the thing is and we will take away 12. Okay, so be a little bit careful. The English there is weird. 12 less than the biggest. So you do the biggest minus 12. The last one, 3, is multiplied together. The product is the answer to a multiplication of the 3 is 51. The product of the 3 sides. So how do we write that? Well, hopefully we recognize we can write A times B times C is equals 51. So these are our 3 equations and our 3 variables, and the solution will be the numbers that when I plug them in make all 3 of these true. Okay, and we're not going to solve them today. Let's look at some examples. And guys, this is from your homework, so I'm going to do about a little less than half of your homework with you, so we can at least do some together. Okay, so let's look at this first one. It's about triangle angles. A triangle has one angle that measures 3 more than twice the smallest angle and is 49 degrees less than the largest angle. So what are the variables here? Well, this is about a triangle. Sometimes it helps to draw it if it's a geometry thing. And it's about the angles. There's one angle, another angle, and another angle. And it says, okay, there's a smallest angle. I'm going to call the smallest angle A because I think that'll be easy for me to remember. The largest angle will be C. That way I can remember it's the biggest one. And the other angle is B. So there's one angle that it compares to the smallest, and it also compares it to the largest angle. So let's see. Choose all the different ones that what are all the different equations that this matches? Hopefully we recognize that one of the angles, B, measures 3 more than. This means we're going to add 3. More than twice the smallest angle. Okay, twice means 2 times the smallest angle. So 2 times the smallest angle, but it's 3 more than that. So one of the angles measures 3 more than twice the smallest angle. So it's 2 times the smallest angle, but it's 3 more than that. So one angle is 3 more than, and just like less than, the more than goes at the end, 3 more than twice the smallest angle. That's what it's 3 more than. Okay. And here's a new one. It is 49 degrees less than the largest. So it is 49 degrees less than the largest. So again, it's talking about the same angle. This one angle is 49 degrees less than the largest angle. So the largest angle we said was C, and it's 49 less than that, and that's B. So these are the 2 equations that are said here, but this is 3 variables. 1, 2, 3. This is only 2 equations. We need a 3rd equation, and sometimes we need to draw on our knowledge of outside knowledge to be able to find a 3rd equation. And in this case, this is about the angles of a triangle. And there's something you should know about the angles of a triangle. When you add up all the angles, A, B, C, of a triangle, they need to always add up to be 180 degrees. And so now we have 3 equations for our 3 variables, and we'll be able to solve this. We'll talk about that next class. Let's look at another type that comes up a lot. So Goofy Golf has 18 holes that are par 3, par 4, and par 5. Okay, you may not know about golf, but par 3 just means it's supposed to take you 3 tries to get to it. It's just like how hard it is. Par 5 means it's supposed to take you 5 tries to get it in. And it's just saying how hard the different ones are. So these are like easy ones, medium ones, and hard ones. So it has 18 holes that are easy, medium, or hard. Most of the holes are par 4. Okay, so most of the holes are medium. That makes sense. In fact, there are 3 times as many par 4s as par 3s. There are 3 more par 5s than par 3s. How many of each type are there? So, which of these equations are represented here? Hopefully, I'm going to, again, try to make, before we get to that, let's try to make sure we make sense of what our variables are. Again, when there's a small, a medium, and a large one, here, I'm going to think of this as the easy ones, the par 3. Par 3s are going to be A. Par 4s are going to be B. So par 3 holes, the easy ones. Par 4 holes. And C is going to be par 5 holes. This is what we want to know. We want to know how many of each type there are. So let's see which of these equations is represented by the things that were said here. Well, it said there are 3 times as many par 4s as par 3. So 3 times as many. 3 times, what is being multiplied? What's the one that's bigger? There are more par 4s than par 3s. So the number of par 4s is going to equal 3 times the number of par 3s. The medium ones, it says most of them are par 4s. So if you do 3 times the easy ones, that's a much bigger number, and it will be the par 3s. So that's one equation. B equals 3 times A. There are 3 more. Notice this time it says 3 times as many. Now it just says 3 more than. There are 3 more par 5s than par 3s. Which one are there more of? Well, there's more par 5s, right? So C is going to equal, we're going to find how many C is, it's going to be however many par 3s there are. That was our A. It's 3 more than that. There are 3 more par 5s than par 3s. That means however many par 3s there are 3 more of these. So we need to take 3 and add it to how many par 3s there were to get how many par 5s there are. So the English here is a little tricky. Okay, now I see 2 so far. This is 2 equations, but I see 3 variables, A, B, and C. So we need a third one. The last thing, and this is really common, is it said there were 18 holes total. And so I know that the total number of 3s, 4s, and 5s, par 3s, par 4s, par 5s, need to add up to be 18. So A plus B plus C has to all add up to be 18, because this is the number of par 3s plus the number of par 4s plus the number of par 5s. So there are my 3 equations. 1, 2, 3. Okay, another type involves prices of stuff. And this isn't bad. Okay, let's see. Jeanette, Raj, and Henry go to a Chinese restaurant. Okay, and they order different combination platters. Jeanette orders 2 portions of fried rice, 1 portion of chicken chow mein. Raj orders some fried rice and some chow mein and some broccoli. Henry orders some broccoli and portions of chow mein. And now we've got the total cost. Jeanette's platter costs $5. Raj's platter costs $5.25. Henry's costs $5.75. How much does 1 portion of chicken chow mein cost? Now, it can be tricky sometimes to see, and you guys will mess this up on your test. You'll lose the points. Some of you will. So be careful here. It can be tricky to see exactly what the variables are. And if people aren't careful, they'll say, like, the variables here are how many orders of fried rice there were. And that's wrong. In this case, you can really use the question to help you figure out what are the variables. Notice the question asks, how much does 1 portion of chicken chow mein cost? So one of the variables is the chicken chow mein cost. That's one of the variables. And in this case, since there's no small, medium, or large, I'm going to use C to represent how much the chicken chow mein costs. That's what we're looking for. So what are the other variables going to be? Well, it's going to be how much the fried rice costs. And I'm going to use F for that. And finally, there is broccoli. There's some broccoli dish. Broccoli. And it's how much it costs. That's what we're looking for. That's what we don't know. We know how many each of them ordered. That's not a variable. What we don't know is how much an individual portion. This is the cost for 1 portion. So 1 portion by itself of chicken chow mein costs some amount. How much does each fried rice cost? Like if you went to the restaurant, what does it say on the menu that they cost? And so we need 3 equations. And we have 3 different situations here. Raj, let's start with Jeanette. Jeanette ordered 2 portions of fried rice and 1 portion of chicken chow mein. So if I take 2 and multiply it times how much the fried rice cost, 2 times F, and I add it to 1 times how much the chicken, I'm not going to write the 1 because 1 times anything is itself, but I could write a 1 there if I wanted. 1 times C. 1 times the order of chicken chow mein. Remember, F is how much the fried rice cost. C is how much the chicken chow mein cost. If she orders 2 of them, she'll have to pay twice for it. If she orders the chicken chow mein, she'll only have to pay once for it. And those prices have to add up to how much her total platter cost, which is $5. So 2 portions of fried rice and 1 chicken adds up to 5. Try to write the other ones on your own. Hopefully you noticed that Raj ordered 1 fried rice, 1 chicken chow mein, and 1 portion of sauteed broccoli. So the rice plus the, fried rice, F, plus the chicken chow mein, plus 1 broccoli, all adds up to be, Raj's total was $5.25. And Henry's cost $5.75. So how can we write a relationship between the variables there? Remember, this is about the costs. Henry ordered 1 portion of broccoli, and that will cost B dollars. And we'll add in 2 portions of chicken chow mein. So 2 times however much the chicken costs. That adds up to be $5.75. Notice some things that are not variables here. Henry is not a variable. First of all, like a variable is something that when you get the answer, like F equals 2 means something. This means that the fried rice costs $2. And if we find that at the end, we're like, oh, the fried rice costs $2. If you said H equals 2, like let's say you said Henry was 2, what does that mean? Henry is 2 years old. Henry is $2. Henry spent $2. We know how much Henry spent total. That's not a variable, and all the other things don't really make sense. Henry is not a variable here. And I sometimes see kids try to say like Jeanette and Henry and Raj are a variable, and that's not true. That's not what we don't know. And again, if you're confused on what the variable should be, look at the question. It can often help you. All right, a track meet. Oh, linear. Oh man, I need to update this to say Navarro. So embarrassing. Navarro. Obviously, I made this when our school was still called Linear. Navarro won in Saturday's track meet with the help of 20 individual placers, earning a combined 68 points. So I'm not clear yet if it's going to be the placers or the points. I could see the variables being about how many people ran or how many points. A first place finish earns 5 points. A second place finish earns 3 points, and a third place finish earns 1 point. Lanier had a strong second place showing with as many second place finishers as first and third place finishers combined. The question is, how many people, Navarro, I guess, Navarro students placed first? It means they won the race. Placed first means they got in first place. They won the race. So how many students placed first? And this is a tip-off for what the variables are. How many students placed first? Well, so the variables are going to be the number of kids who came in first. Our second variable is the number of kids who came in second. And our last variable is the number of kids who came in third. Now, they gave us a lot of information about points, but the question is about how many kids came in first. So I also want to know how many came in second and third to write my system of equations. So with that in mind, let's write some equations. Hopefully you see that there were 20 total placers, kids who came in first, second, or third. And so I didn't define this variable. These variables, I'm sorry. A, B, and C. Okay, so A is going to be the number of kids who came in first, B is the number of kids who came in second, C is the number of kids who came in third. So what are the 3 equations we need? Well, if there are 20 total finishers who came in first, second, or third, then the number of kids who came in first, plus the number of kids who came in second, plus the number of kids who came in third, adds up to be 20. Next, I know that they earned 68 points total. That's not A plus B plus C. If you add up the number of kids, that's not the total number of points. This is about kids. This next equation is going to be the total number of points, right? So how do we find the total number of points? Well, however many kids came in first place, we'll multiply that by 5 because that's how many points they earned. Each person who came in first earned 5 points. So it'll be 5 times the number of kids who came in first. plus 3 times the number of kids who came in second, plus however many kids came in third, that's how many points they'll earn because each kid got 1 point. So is this enough equations? No, this is 2 equations for 3 variables. The last thing says there were as many second place finishers as first and third combined. So it's talking about the number of second place finishers. It's saying the number of second place finishers, that's B, is the number of first and third place finishers combined. So the number of first and third place finishers combined. And those are our 3 equations. Hopefully you feel okay about that. All right, let's do 3 kind of tricky ones and then we'll be done. Your aunt receives an inheritance. That means when somebody died, they left her $20,000. Wow, so lucky. She wants to put some of the money into a savings account that earns 2% interest annually and invest the rest in certificates of deposit, which are called CDs and bonds. Okay, so she's going to have a savings account. So she's putting the money into a savings account. The rest is going to go in certificates of deposit and bonds. A broker tells her that CDs pay 5% interest annually and bonds pay 6% of interest annually. She wants to earn $1,000 of interest per year, and she wants to put twice as much money in CDs as bonds. How much should she put in each type of investment? Okay, so what are the variables? Well, look at the question. How much should she put in each type of investment? What are the types of investments? So this is the money she puts in a savings account. That's going to be one variable. Then she puts some money in CDs. So money in CDs, because we want to know how much money she put in each of these things. And money in bonds. So that's the 3 things she's putting her money into. And so I'm going to use letters to help me remember this. I'm going to choose S for savings account, C for CDs, and B for bonds. That way I can remember easily what each thing is about. Okay, now I know what are the equations that are going to match here. This is tricky. Let's just do it one at a time. Your aunt receives an inheritance of $20,000, and she puts all of the money in these different things. So what has to be true? Well, B plus C plus S has to equal $20,000. However much she puts in all 3 of them adds up to $20,000. It also says, I see that she wants to put twice as much in CDs as in bonds. So the amount she's going to put in CDs is equal to twice as much as the bonds. So she's putting twice, the amount that's going to be in the CDs is 2 times the amount in the bonds. That's what it means. If you're having trouble like realizing, like if you might have thought it was B equals 2 times C, but that's not what the English says here. It says she's going to put twice as much in CDs. So the C has to end up being bigger. So we'll take whatever the B is and multiply it by 2, and that will give you the CDs because it's going to be twice as much in CDs. So her CDs are going to be more. Okay, the last thing is she wants to earn $1,000 in interest per year. Now, this is not an exponential equation, but it does sort of involve a similar idea. She earns 2% from her savings account, 5% from CDs, and 6% from bonds annually. And at the end of the year, this all needs to add up to $1,000. Okay, so what is adding up to $1,000? Well, it's not B plus C plus S. That adds up to 20,000. What's adding up to 1,000 is 0.02 times S. However much money she puts into savings, she's going to earn 2%. That's 2 out of 100. That's how much money she's earning from the savings account each year. And she's going to earn 5% for however much she puts into CDs. And she's going to earn, oh man, this got messy, 0.06 times B. I apologize for the messiness here. If we had 0.02 times S, that's how much money interest she's earning from savings by the end of the year, how much she's earning from CDs at the end of the year, and how much she's earning from bonds at the end of the year. Notice that this is just the interest. This is how much money she's going to end up with left over, in addition to how much she started. So we didn't add in 1 at the beginning because we're not saying, how much money will she have. She would end up with 21,000. If it had said she wants to end up with 21,000, then we would put a 1 here to show that she would get back to how much she already had plus add in the interest. Two more. A parabola goes through the points -1, 2, 1, 8, and 2, 5. Write an equation for the parabola in standard form. And the standard form of a parabola is y equals ax squared plus bx plus c. Now, we want to find this equation. So what are the actual variables we're looking for here? We want to find out what a is, we want to find out what b is, and we want to find out what c is. These are our three variables that we want to find, because maybe it'll be like y equals 7x squared minus 2x plus 18. I don't know. Like maybe that's what happens when we find out what a, b, and c are. We'll be able to find out what the equation of the parabola is. Notice that y and x are not actually variables here. So when we write our equations, it's not going to end up having y and x in it, because that's not one of the variables we're looking for. And it tells us 3 points it goes through. This is an x and a y. And so what we can do here is we can plug in x and y to get an equation with just a, b, and c. So for our first equation, y is going to be 2. And x is going to be -1. And so it's going to be a times -1 squared plus b times -1 plus c. So notice I put in x for, or 2 for y, and -1 for x. And this can simplify. -1 squared, I'm going to put 2 equals, -1 times -1 is +1, and that coefficient usually goes in front. 1 times a is just a. That's the simplified way to write it. -1 times b will be minus b. Positive times a negative is a negative, and then the c is just there. So this is the simplified way to write the equation. Go ahead and write what would the equation be for 1, 8 at the point 1, 8? What equation will that give us? And simplify it. Make sure it's simplified. And hopefully we notice that y will be 8 here, and x will be 1. So we will get 8, because that's y, equals a times 1 squared plus b times 1 plus c. Now, this will simplify. 1 times 1 is 1, and 1 times a is just a. So it'll just be a. b times 1 is just b. We don't need to put the 1 in front. And c is c. And our last equation will be from this point. Go ahead and try that on your own also. And hopefully we notice that the y will be 5. So 5 equals, that's y equals ax squared. So a times x is going to be 2. So 2 squared plus b times 2 plus c. 2 squared is 4. So 5 equals 4a plus 2b plus c. That's the simplified way to write it. All right, I think we're going to stop there, guys. I will tell you, I'll give you a hint on this last one, but we're about out of time here. It's asking for the y-intercept of the third line. So there's 3 lines, y equals mx plus b, y equals mx plus b, y equals mx plus b, but they're not going to all have the same variable. The b for this third line is what we're actually looking for. So that's one of the variables. It says line with a slope of 2 and a y-intercept of 1, a line with a slope of 3 and a y-intercept of -4, and a line with a slope of -1 all intersect at the same point. That means all of them will have the same x and y. And so notice it tells us the slopes and the y-intercepts for everything except for the third line, but they will all intersect at the same point, so they'll all have the same x and y, and those will be the variables. The variables will be x, y, and b for the third line. All right, guys, try writing these on your own. It's important to get practice on this. I will tell you, especially if English isn't your first language, writing down these equations can kind of be the hardest part of systems of equations. So let's get good practice here.